looking at is the front end of the BAS for the Drexel Academic Tower. Web control is set up with an interface that has a navigation pane on the left-hand side where you're going to see geographic locations, basically floors, pieces of equipment on that floor, everything broken down in that format. And then across the top, there are different options or tabs that you can use to navigate around. So, for example, when I click on the ground floor, it shows me a floor plan of the ground floor. We have the second floor. We have our thermographic floor plans. These are the first level of graphics that you're going to interface with on the system. What they tell you is information that's easy to digest by simply looking at the entire floor. So right now, by looking at the second floor, I can see that the majority of my rooms are in green. That's telling me the temperatures are between set points. It's right where it needs to be. I have a few rooms that are light blue. That means they're slightly below. They're a little colder than they need to be. And I got a few rooms in dark blue. That means they're a little colder than that, but not quite to the alarm level. And then if we look over here, we got a couple in red, which tells me that they're most likely in alarm. So in this case, we have our zone temperatures 80 degrees in that room. Our set point 75. That's why it's red. It's a little hot in there today. So I'll preface this by saying that we're probably going to see some alarms today on floor plans because you guys are working in rooms. There's still construction going on in certain areas.
Can you give us a floor plan?
Sure. The third floor?
Yeah, I just want to see for that floor. I assume the sun's over there right now?
Sun's over this way, I believe, right? So I think it's I think that room we were looking at on the second floor. Is this the fire pump room? No.
That's the fire pump room is on the ground floor.
That's too big. Too big. But you're correct. Could be the sun's in that room right now. Yeah. So the layout that we have, these thermographics are going to give you information about the room. Right here is an indication that we're not communicating to a controller, so they usually show up in a purple color. The other thing that will show up would be any alarms. So if you have an alarm in the room, and let's say the room temperature is where it needs to be, and this room's green, but all of a sudden the VAV fails, okay? And we're not getting the flow we need, and it triggers an alarm. When that alarm goes off, even though it's the right temperature, the whole space will go red, right? So it's an easy, quick way for you to go through and quickly look at the state of a building, right? So as we get a little further up into the office, more office-y type spaces, there becomes more and more rooms and things become a little more busy on the screen. So now, once we go into a specific room, let's take a look at, we'll start in a second, for a specific area. Now, in the geotree, we have an entry in every side for every particular room in the floor plan itself. So, room 2W18 corresponds to what we see as 2W18 over here. So, I can either click on the room there to go, and you can see that it shows me that I went to that room. Now, for example, apparently there's a download parameter required. So if I go into that room, it kind of gives us a breakdown of what is in that room. So we have a chilled beam, we have a radiant heating panel, we have a custom trend graph that we have embedded in the graphic, and right now it's just tracking what the zone temp is. We can configure that, and you guys can configure that to show whatever you want, right? And we'll talk a little more about that when we get to trending, all right? So, but we also see our VAV, we see our occupancy sensor, and then some statuses on valves and whatnot. So, this particular space is, these particular spaces are generally handled by multiple different controllers. So that's something that Nolan worked a little bit on, and if you would like, I can have him talk a little more about how it's laid out.
So in this room in particular, we've actually got multiple VAVs in one room. In that case, the way our VAV controllers work, they basically bolt right onto the side of the VAV. So that means if you have a room with multiple VAVs, usually we'll have a controller on each, and then we network the information for that lab or for that room between the controllers. So the temperature sensor goes back to one of the VAVs. Over the network, it sends that information to the next VAV, to the next controller. Also, they're all controlling to the same set points at the same time. In this case in particular, there's actually 3 controllers in this room. There's one for each VAV, and you can kind of, it's fairly intuitive, and then you can just look at the name of the room, the prefix in your in the VO tree over here on the left-hand side. You can see that there's 2 VSs, VS204 and 203, and then there's a third controller that controls the radiant valve for this space. This controller receives its demand signal from whichever controller has its temperature sensor. So this is kind of like the brain of the whole space, and whatever it decides the other VAV needs to do, or the cooling valve needs to do, or the radiant valve needs to do, it sends that information where it needs to go.
And we refer to that as a parent-child, right?
Yep. We've kind of got all of this broken up, as Jim said, into parent-child relationships. So the parent program will always have a parentheses P next to it, and the child program will always have parentheses C next to it. That's not the case for every single room in your building. It's really only the case. The more equipment you have in the room, the more controllers you need to control the room. Up here, we've got some much more straightforward, just a single VAV and a kill beam. All that's done off of one controller.
So really what to take out of that comment there is anytime you see a P and a C is that if you want to look at the main controller for that room, it's going to be the one that has a parenthetically referenced P. Right?
When you're on the thermographic on this level, if you click into one of these rooms, you're actually clicking on a link to take you to the parent program. It's not going to take you directly to any of the child programs.
So that's just the basic.
Correct. So just for example, 2W05 takes you to the parent program for 2W05. There is a child program there, and you can get to that one. There's usually links baked into the graphic for that right here. I don't think it's in the child.
So the parent is the overall.
Yes.
Yeah.
Yep.
So I would say probably 90% of any troubleshooting you do for a room is going to take place in the parent. And then once you identify what the issue is, maybe you might have to go to the child. But if you go to the graphic for the parent, it's going to have everything on it, and you're going to be able to see it, and you say, okay, well now I'm having trouble with my radiant panel. I need to click on this link, and it'll take me right to that. So we've tried to bake in as many different ways to get to the same place as possible, so that you guys can figure out and customize how you're going to look at things and how you're going to go through and manage the building. Ready? Rock and roll. So that's a high level review of of how the floors break out. So we can talk about the different types of equipment that you have. Most of the stuff are VAVs, radiant panels, and chilled beams. There are some areas that are covered by fan coil units, which do have the new handy dandy advanced graphics package. Of course, I clicked on one that's not.
And I'm gonna show you when you go to the child. Right?
Yeah, so we're looking here. This is so sometimes on the are any of these papers? Well, we can look at a fan coil on a different 12. No, that's integrated though. Not all of them? Okay. So for the most part through the building, there are some fan coil units. There we go, here's one. So there are some fan coil units. They do use the new advanced graphics package. That's another type of equipment that we have. There are some unique aspects to each floor. So one of the things that's happening is up from the ground floor to 6, we're monitoring the fire smoke dampers in the column. There are two separate columns of air that come from the air handlers that are delivered to the floor. Okay, and on ground floor through 6, we simply monitor the state of those fire smoke dampers because it's constant volume. There's no modulation. Once we get to the 7th floor, there's no terminal units. There are no VAVs or anything like that. There's just chill beams, and so those same fire smoke dampers modulate. And so we target a specific, just like a giant VAV for the entire floor, the fire smoke damper modulates to control how much air goes into the floor and how much air comes out. So those controls are generally at the bottom of each of the geo lists for the floor. And here's one for the 3rd floor where we're showing them they say they're open but they're closed. There's the geo list for the floor, and well, that one's right. So these are closed right now. And then if we go to the 7th floor and we take a look at our airflow control. Is it not a graph? Doesn't look like it. All right. So let's talk about our I/O.
Are you measuring CFM?
Yes. There's an Edtron airflow station on
7 through 11.
7 through 11 on the supply and the exhaust. Okay. So there's also a third riser besides the main supply and the main exhaust, but it's a constant volume exhaust. It does like the bathrooms, and there's no airflow station on that because it runs on a dumb fan that turns on, turns off, and it's all balanced, no modulating control, nothing, right? Totally constant. So it looks like this is a good place to talk about. Our I/O page. So, for example, for the 7th floor west airflow control, when you look across the top, you get all these different options. One of them would be like you saw for the fan flow unit, we have a graphic, okay? But then you have properties, and if we go here to our properties, the most common page that our guys use when we're installing is this page here. And that's our physical I/O for the system, okay? So this is where you're going to see those airflow stations. This is where we're going to see the binary points, the end switches coming in. All the hardwired I/O for the controller is located here, which I'm sure you guys are familiar with. There's also many other properties tabs that tell you different things about the system. You can see what the different alarm sources are, configure them. You can see the different trend sources, configure them. So one of the ways you might use the trend sources tab would be, I'm having trouble with a room and the fan, I'm getting told that the fans for this fan coil unit is turning on and off. But it's happening inside of 5 minutes, okay? Generally, as a default, we take a sample every 5 minutes. So if this problem happens for 30 seconds and then the fan comes right back on, if that's in between those two samples, it might not work well, right? You might not be able to see it happening and diagnose the problem. So maybe when you're troubleshooting, you want to come here and you want to change that time frame for that particular point, and you can do so right here. You can change the 5 minutes down to 30 seconds. And now you got to sample every 30 seconds, and you can see what's happening with the system. A little more common maybe if we're talking about temperature control, discharge temperature control. All of a sudden you have a valve that might be hunting, but if you're only seeing this every 5 minutes, it hunts, goes all the way open, slugs a whole bunch of cold or hot air, and then closes off again, and now you take another sample and the valve's back at a position it normally would be in, right? So this is a place where you can come and you can make those changes and for the sake of troubleshooting. And we'll talk a little bit more about that when we get to the main trending, when we talk more about trending. So here's network points. Most of these aren't being used. BACnet objects. This is actually every BACnet object inside of the controller. Outside of a physical I/O, there's also all types of points that are available to the rest of the system from this controller or to any system that connects to the BAS via BACnet. So this is where you can come and see how that BACnet object is addressed. And these barely ever get used. We don't need to talk about it. So the next thing I can talk about is, before we move on to maybe mechanical equipment, the penthouse equipment, is scheduling. How familiar are you guys with scheduling with the automated logic? All right, pretty easy. Right now we have a 24/7 schedule, never turns off. But the scheduling structure for for automated logic is hierarchical. That means that you can set a schedule either specifically at the device, or you can set at the location, or at the entire site. And if I set a schedule at the floor, it'll apply to everything below that floor. But then let's say there's one device I want to have a slightly different schedule. Now I can go to that device, I can click there, I can add a schedule to that one, and it'll only apply to that device, and everything else will use the previous schedule.
Will that apply to, if you add something to floor 7, will that also floor 8?
No. If you wanted it to be all the floors, you'd have to go to the full site. And you add it there, and then it applies to everything. But if you add it just to the second floor, it's just the second floor. And then so on as you get further and further down the line.
There are some more advanced applications too that we can talk about later, or maybe in one of the office trainings. Sure. You can create scheduled groups. So if you wanted to easily say every fan coil is on a specific schedule, and you don't want to move the fan coils every area, you can add all your fan coils to that schedule group, and now they listen to the schedule for that group, not for that floor.
So one of the applications for that might be data rooms. Now you say, okay, well I don't want my data room to be on any kind of the same schedule as all the occupied spaces. And there's data rooms on every floor. Now you can make a group out of your FCUs, and they'll follow their own data room schedule. The vast majority of the application of that is our mechanical spaces throughout the building. The vast majority of every other application gets done through the GUI. So maybe 2% of scheduling actually gets done with a group, but it's a powerful thing, and if you have it, it's nice. It makes things really easy. All right. So let's talk a little bit about, we can kind of get into the penthouse. You want to talk about the 12th floor at all?
Let's say page 6.
Page 6, and then come back to the 12th floor. Okay. So I'll start off here, and we'll talk about the penthouse itself. We'll start with the air handlers, and then we'll work our way out to the other plant systems. Come on, buddy. There we go. So right now, the building it's constructed has 4 air handlers on the main delivery system. They all service a common plenum for both the supply and the exhaust. What that means is one of the air handlers goes down. We have to make sure that isolation dampers on the OA and the supply and the exhaust and the return all close, because we can lose air from the plenum through it. So all of that type of functionality is hardwired to the VFD. So what that means is that if for some reason you wanted to turn a fan on its hand, if you go and turn the fan on its hand, that VFD is going to open those dampers. Okay? If the VFD falls out and shuts down, the VFD is going to shut those dampers. Okay? So there's the potential for a problem of backwards flowing air through a unit has been minimized as much as possible. Obviously, we all know you can have a damper that seizes up, you can have a bad actuator, so the potential still exists for it to happen, but it's not going to happen because of the controllers. The VFD shuts down. Both VFDs, like we have one faulted out here right now. If the second VFD shut down, the entire unit would shut down, and we would close off all 4 points. Okay? So that's important both on the shutdown sequence as well as the startup sequence. So when a unit starts up, it also means that the fans have to start before we open those dampers. Because if we don't, if we just open the dampers and then try to start the fans, and the other units are running, air is going to rush through and spin the fan backwards, and you can fault out the VFD and it definitely won't start. Okay? So what that means is that a long way of me saying, if you have to restart one of these air handlers, you should expect to see the fan start before the damper opens. The fan will start and run to a minimum speed set to the VFD. So that minimum speed is usually 1/3 of its maximum. And the dampers the dampers here in the discharge of the supply and the dampers in the exhaust are all rated for 8 inches of pressure. So running a fan at minimum against those dampers should not cause you a problem, right? So once you hit a certain pressure, as read right here at the discharge, once we read a certain pressure, then the damper opens. So as long as the VFD gets to its minimum speed, we read a pressure, damper opens. So then now you open to the plenum, fan's already spinning the right direction, and it can then come up to speed. All 4 of the air handlers are designed to run at the same time all the time. There's no staging, there's no modulation, there's no we're gonna turn one off because there's no demand in the building. All 4 run all the time. Fans modulate up and down in unison. So there's a common signal that is spread across all of the air handlers, and all air handler speeds should be locked together, both on the exhaust and on the supply. Those on static. That is based on a large number of sensors out in space. And the reason why it's so many more than we would normally see is because there has to be redundancy. Each air handler has 2 remote sensors associated with it. So if there's 4 air handlers and each has 2, that means there's 8 total on the supply and there's 8 total on the exhaust. So what we look at is the worst case scenario in the building, and we control the duct static pressure to that worst case scenario. If for some reason someone comes along with a sawzall and cuts the conduit from air handler 1 to air handler 2, and air handler 1 is no longer getting that common signal, we have logic built in there that looks at this pressure all the time. And so as the air handler is running normally, we're making 3.25. It looks at that, and every minute it records that. And if it loses comm to the other air handlers, it makes that pressure its current set point and controls to the discharge at that set point. So your air handlers will have basically a limp mode, and they'll work properly and control to their discharge for a period of time. As stuff changes down in the space, now that pressure is going to be different than what the air handler would need to supply, and it might cause a problem. But at the very least, that's going to get you some time. The unit will throw an alarm that comm went down, and the unit will continue to operate, saying, hey, I can't talk to the rest of the air handlers, but I'm going to keep making this pressure until you guys figure out why, right? So you would think it would probably give you at least a half an hour to an hour before you start to see differences in the speeds of the fans. So now, if they're disconnected, now you have air handler 1 and air handler 2, and their fan speeds are going to start to drift. If they drift too much serving the common plenum, it can cause vibrations and problems in airflow in the system. So there's some safety built in. As soon as it happens, the unit will throw an alarm. It'll tell you guys that there's a problem, but it'll keep delivering air.
And every unit has hardwired duct pressure safety, so there's not going to be a scenario where one just ramps out of control, blows apart ductwork, it'll shut down long before that ever gets.
High static and low static?
Supply and exhaust side, you have switches built in and a manual reset right on the side of the unit.
Every point that you would have a pressure safety on, it has it. There's nothing missing. I'll tell you this, initially they had us put the pressure safety that is, it's actually it's the same place. The pressure safety that's located here, they wanted us to put it here, and there's just no reason to have it there at the high pressure, so we moved it over. Every point that you can monitor we have, and maybe that's a good opportunity to start to talk about safety, right? So we have pressure monitoring on the supply and the exhaust to protect the ductwork from the fan pressure. We also have a free stat array associated with the entering area of the chilled water coil that is designed to protect both the chilled water coil and the hot water coil. What other safety am I missing? Tie in all the end switches.
Yeah, end switches, high static, low static, smokes, fire alarm, not that.
Fire alarm. not so much a smoke detector, but we have a fire alarm relay that we're picking up. So when the fire alarm does go off, trips that relay, all the units will shut down. You don't have a direct connection to the smoke detector, but that's not all that common anymore. Most of the time, we just get a fire alarm.
Are they designed differently now? I mean,
Well-
everything over 2,000 CFM.
Well, no, it has a smoke detector. So, like previously, what we used to do, we would actually pick up contacts right on the smoke detector
Right.
and tell if it tripped. Nowadays, what happens is the fire alarm system has the smoke detector tied into it, and then there's a relay, and it makes a decision as to whether it closes that relay for us. So,
If there's 4 or 5 different smoke detectors on the unit, we're just picking up one.
we only get one signal, so we don't know if it's the return, we don't know if it's the exhaust.
The
We
fire
just-
alarm looks like
Yeah, the fire alarm system would tell you, right? So it's more and more common, especially in large buildings. So safety-wise, so a part of that logic, and when we go and we take a look at one of these enclosures, you'll see, we'll point out those safety relays and where they all exist. All of these things are hardwired to an individual relay. It makes it the easiest to troubleshoot. It also makes it the easiest to test. If you want to test how it works, you literally go up to the ICP relay, the right one, pop it out, and it'll perform the action that it's supposed that you would expect it to. We'll see that when we walk over and take a look at the can. Both units, all 4 units have 2 energy wheels, a total energy wheel and a sensible energy wheel. Right now, the sensible energy wheel is not running in this unit, only the total energy wheel. These are devices that are controlled and modulated by their own local controller. It's by Thermotech. We do have an integration to it, and we have the ability to write set points. That's about it. So there's that's sufficient to control energy wheels in a unit. But if you said to me, hey, I want to discreetly tell it exactly what speed to run, it's possible to do it. But generally, how we interface with it is by giving it a set point. Say, hit this set point, hit the, turn yourself on, increase your speed when the return enthalpy is different than the supply enthalpy, that kind of thing. So, and all of that is baked into the logic for this control. It's all integrated in. Over here in the geo tree, we can actually see the place where we're picking up the wheels, and all of that information is being recorded and trended in the web control system. Both analog and digital points, as well as the three alarm points that come out of the unit. So right now, this one of these alarms is actually an alarm that triggers a relay contacts. So there's a relay, and there's normally open and there's normally closed, and it throws an alarm, whether if it's in the normally open position or if it's normally closed. So we have to turn off one of the alarms, because if not, it would always be an alarm. Let's see. Low speed. So right now it's telling us that we have a low speed alarm on the sensible wheel, which we can kind of go back to the air handler itself and see that that's 100% the case. Literally, low speed is no speed. It is not running. So all of the graphics, especially the advanced graphics package, if we have discrete control over something, meaning that I can tell it to start and I can get a status on it, then in the graphics package, if the unit does fail, you're going to get this. You're going to get a blinking. It's going to blink in red to tell you that it's failing on the screen. For the wheels themselves, they will also blink, but it just needs to be mapped. So that particular alarm needs to be mapped to this wheel, so it will blink and tell you it's not running. But it is registering the alarm at the time. Filters. You guys are happy? Yeah, you can hear we're still mid-screen. So on this screen as well, there's a spot for custom trend graphs. You can see them down here. This is actually, I have them set up as placeholders for data on the energy wheel. And that's a good way to transition into talking about trends. So, how many trends?
I got it all on one screen.
Yeah. the custom trends. So when I started working for Radius, the trending has always been a part of automated logic system, but what I realized very quickly was that if you ever have problems, the way that you always fix them, it always centers around the trends tab. Everything centers on that. And so that was something that I like to drive in all the graphics, is building not just a single trend, like showing just what the supplier temperature was, but a trend that has multiple points inside of it that help with that help to do troubleshooting and help to show you what's actually happening in the unit. So right now we're still operating these at a discharge temperature that is slightly higher than what they would be for design. They're still running the way they were for the past year during construction. So that's why what you're seeing here looks like a little bit of hunting. We're also seeing it well above the set point. So if I go in and we see this particular trend graph at the top, supplier temperature versus set point, custom trends are housed here in this drop down. So if I go over here and I say SAT versus set point, now it takes me into specifically that trend. And it gives me the ability from the trend itself to see all different types of information. So up here across the top, the basics are, first thing is calendar. What do I want to look at right now? Well, what's it configured to? This custom trend graph is configured to show me 3 hours of information. Because for supplier temperature, generally you want to look at something that happened recently. So you want to look at the last 3 hours. But now let's say I want to see what happened over the last week. I can go back to the view, I click on my calendar, I click on week, right? It shows me everything that it's been doing for the past week. I want to see it for a month, I can see it for a month. Great control, by the way, right? Not really knocking it out of the park. This will always default on the view back to 3 hours. It's configured that way, right? Some of the other buttons here. Right now, if I wanted to move around in this graph, I click and drag. If I want to zoom in, I click here, and I zoom in. Easy, very, very simple stuff. Revert back, always click on the view, and it'll revert back to whatever the default you have set. So this is a scale to fit. If you have a large amount of information and it's off the page and you want to scale it down, you click on that button. It's obviously all on the screen now, so it's not doing it. On the other side, this is where you can set some different parameters for how you view the trends in the field. So now let's say you have a problem piece of equipment and you want to actively watch it while you're sitting at your desk. If you click this option here to auto update from the field, now every time a new trend sample comes in, while this screen is up, it'll add it in. Without that checked, it populates what you had at the time you populated it, and it waits until you refresh it to show you anything new. So it's basically like an active refresh. Show database values only kind of takes anything out of the graphic that hasn't been logged at the server. So we store a lot of our trend information right in the controller, and then periodically dump it to the server. If you only for some reason wanted to see what was in the server and not in the controller, check that box. You can check that box, and it'll only show you what's in what's in the server.
Do they stay there?
No, they always, anytime you go somewhere else and come back, those options are, you got it. This one here is always checked for adding in spots where there might be missing data, but the other three always default back to being on. And then, now let's say you wanted to grab this information and use it somewhere else. Email it to a colleague or send it off to your boss or something like that. Right here, this is where you can come and you can save this particular trend graph as whatever format is available. So if you want it as something you can open in spreadsheet, it's just going to show you all that info in a spreadsheet. You can grab a CSV file, and then if you want to send it as an email, maybe you want a PDF, maybe you want something a little higher quality, some sort of an image file like a PNG, a JPEG, or an SVG image, you can get it here as well. Also, one other thing I'll come back around to, kind of overarching, is the help functionality for the system is robust. So it actually does have, and it's tailored to the location you're in. So if I click on help while I'm looking at a trend, it takes me right to the section that starts off to tell you about trending. So So it's going to give you all different types of information about what you need to know and how to build a trend and any question that you might have.
So if you have access to web control and you hit that help button, you'll always be able to get to that menu. It doesn't take you out to the internet.
Right.
All of those pages are baked right into the database.
That's
so
correct.
It doesn't require the internet.
Now, they're not in place yet. That also allows us to talk a little bit about the document vault. Every site that we have has a document vault that contains all the as-builts, all the cut sheets, everything, and that is also local to the system. Generally, we don't add those in until we have a permanent server for the site. We don't have a permanent server here yet. We're not going to take up space with that type of material. There are not only documents, there are also 26 training views. Yeah, it's a large amount of space. That's why we usually wait till the permanent server goes in. We don't put it on the little machine. So there's a 26 different training videos, and you'll recognize the person's voice on them because I recorded it. So there's training videos that a colleague of mine and I put together that are actually screen captures of people executing different functions, and you can watch it, and I talk about what we're actually doing, and it's a really good resource, and we put them on every job site. So good place to get cut sheets on I/O devices, cut sheets on our controllers, as-built documentation that will show you wiring layouts, floor plans, everything like that, wiring diagrams for the equipment, and then in addition to that, there's training material that's there as well. Like that's boilerplate stuff, so we're going to show where it would be. Yeah. We always put them here. It's right now it's blank because we don't have the permanent server. So, but this is the document vault, and there'll be a graphic associated with it that has links to all of those things on it. And again, same situation that Nolan just mentioned. You don't have to have an outside connection. It's all local to the server. So whether it has internet or not, whatever the situation is, you'll always be able to get it. All right, so let's head back.
Where is the server?
The server, right now, this is the construction server behind us. We are still waiting for direction on where we are to install. The server for this site is going to be not a rack. It's not going in a rack. It'll be a workstation. Yeah, workstation machine. A little bit higher end than a standard workstation, but I think that there were a couple of locations. There's like an office up here that it was supposed to go into, something like that. So we're waiting right now to hear where we do. One of the things that our service group does, talking about the server, one of the things that our service group does, and the construction group, we do it as well, is constant backup. So we take a constant backup of the system, and generally speaking, that'll be once a month, once a split, if a service guy's doing it. We tend to do it on construction at the end of every day, maybe at the worst at the end of every evening. And that way, if for some reason the server crashes out and we can't recover the system from it, the worst case scenario is you'll lose maybe a week's worth of information, trend-wise, and we can turn it around. So making a replicant or making a backup of the system on web control is extremely easy. It can be time-consuming if you want to include all the trend data. But if you're only worried about the functionality of the system and being able to bring it back online so it can start accruing trends again, generally it's a process that's measured in minutes, not hours. Okay? So we talked a little bit about the air handlers. Do you guys have any questions about the air handlers before we move on to some of the plant stuff?
You want to talk about AHU6 before we move?
Yeah, let's talk about AHU6 before we go off to the plant stuff. And maybe a good thing to do is after that, we get up and walk around and look at some, so not everybody, so we're not sitting forever.
So first thing, I want to apologize for this. This was previously an automatic, and I just checked this morning. Both of the drives on this unit are in hand. I don't know if the balancer was messing with it. I don't know. Regardless, the unit is running right now. It is supplying air. This is your air handler for the 12th floor lab space. There's a lot of similarities between this unit and air handlers 1 through 4. There's some important differences. This is the only air handler for the 12th floor. It's not a common plenum with 3 other units. This unit goes down, you lose supply airflow on the 12th floor. Has 2 supply fans, The exhaust side doesn't have its own built-in exhaust. That's actually the lab exhaust fan up at the roof level. We can talk about those after we talk about this. There are, I think they're Greenheck or Strobic exhaust fans.
Greenheck.
The plume exhaust.
Right on.
So the exhaust side of this unit, this is being drawn through and then up out of the building. On the exhaust side, rather than the two sensible and total energy wheels you have in air handlers 1 through 4, you have a glycol loop that basically you have a coil in your exhaust stream, you have two pipes, you have a set of pumps, and you have a coil in your supply. And it just, under certain outside air conditions, it enables that system for either heating or cooling, and it just runs those pumps and circulates one of them. The other key difference between this unit and air handlers 1 through 4, you have a preheat valve, a cooling valve. That's the same. You do not have a reheat valve. All reheat is done at the labs themselves. Every lab, all the supply boxes will have reheat coils in them to bring the temperature back up to what's appropriate for the lab.
There are some VAVs, but the majority of it's Phoenix. They're pressure independent.
Yep. So we'll talk about the Phoenix stuff. Yeah, it's a separate system that we're pulling data from. Other than that, this unit is extremely similar to air handlers 1 through 4. It doesn't look for set points from other units. It has its own set points right on the unit. I believe there's a reset on the static pressure set point. So based on demands from the space, from the Phoenix equipment, and from our equipment, that we'll see that pressure set point kind of increase and decrease. You have a static discharge temperature set point. It should always be 49 degrees. It's very cold because there's lots of cold spaces on that.
49?
Yeah, it's very cold. Yeah.
Well, there's the cadaver labs, so they need to stay very, very cold.
Yep. And it's generally going to keep it pretty dry on that floor as well. You'll have your Phoenix equipment reheating all that air. You're going to have pretty dry, but room temperature air. That's really all there is. That's about all there is to this unit. There are multiple static pressure sensors throughout the floor, I believe. I believe there's 3 supply static pressure sensors and 3 exhaust static pressure sensors distributed in the different locations of the ductwork of the floor. Just with AHU 1 through 4, it looks at the one that is furthest from set point to control the fans. For those supply, on the exhaust, I think they're doing the same. That's a separate controller.
Does the VFD on air handler 6, does the VFD also control the damper, or is that?
Yes.
So that's another situation for that where if you did put the fan in hand, it should open the damper on its own. You shouldn't have to go to it and crank it. For whatever reason, worst case, you're walking around and putting switches and trying to get the air moving. You shouldn't have to crank the damper open, put the VFD in hand, it should also open the damper.
We don't have the same concerns on this unit because we don't have a common plenum. We don't have the same concerns about air blowing backwards through the unit, but the unit still isolates itself when it's off. So we do have the dampers there, and as Jim said, the VFD will control the dampers based on what the VFD is commanded to do. This unit basically just runs 24/7. There is no schedule. Being lab space, there is no scenario where you don't want this unit to run. And the same applies to the lab exhaust system. You want airflow all the time. It doesn't matter what the scenario is.
So there's 2 supply fans, right? There's
Yep.
like the fan wall or something?
Yes, they're basically just right next to each other in the unit. And there's no staging of each fan. It's just a little bit of
Run at the
redundancy.
same time?
Yes, run same time, same speed. It's a little bit of redundancy. If one fails, you still got airflow.
Still have the, can the one handle the load?
I don't believe it's sized for the full load, although right now it looks like it's doing all right. As I said, one of them is
25%
off.
speed though.
Well, it's not actually at 25.
We're telling it 25.
Both of them are in
Right.
hand. One of them is in hand off. The other one is in hand, I think at like 50 hertz. But that's still not max. And we're seeing 3.1 inches at the discharge of the unit. So it does all right on one fan. It's not.
Yeah, we're twice the set point remote of it in hand. So I think one fan running is probably not all good. But see, the thing we don't know right now is what conditions all the stuff down in space. So it might be, we might have because it's a blend of both Phoenix valves and pressure dependent VAVs, we do have a static discharge reset where if it was all Phoenix stuff, we would have one number, we'd try to hit that the lowest possible to make sure all the valves will work, and we'd be good to go. But because we have the pressure dependent stuff, we might have to ratchet the fan that set point up and down to accommodate depending on the position. So,
Same thing with the exhaust there too.
yes.
So the exhaust, this is just basically, you can think of this as the other half of this unit. This is designed to normally run one fan. If the fan speed is high enough, and I don't know how familiar you guys are with exhaust or lab exhaust fan control, but the basic premise is that you're blowing air as high as possible to make it safe to evacuate those whatever you're pulling out of your lab.
Disperse the atoms as much as possible.
So you're trying to get that boom height sufficiently high so that the EPA calls it safe, right?
And nothing cools on the roof. So if somebody has to go out there and work, they're not going to go in and breathe in a bunch of nasty stuff. Right?
So because of that, you're normally going to see your fans running fairly hard. If you don't have I don't think we have a final number for the balancer yet, what that number is, but usually we're talking 70, 80, 85%. The pressure control is done primarily by your bypass dampers here. All that does is, as pressure gets below set point, so you have too much suction in your duct, bypass dampers will open and just allow outside air to cycle through those exhaust fans up and out. If your pressure is not sufficient and your dampers are fully closed, then your fans will increase speed. Under that scenario, if your dampers are closed and your fan, normally if you just had one fan when we first started the system, that fan will ramp up 95, 100%. It'll bring on another fan. It's designed to always run one or two fans depending on the pressure requirements of your duct.
Are these configured as lead lag or lead lag standby?
Lead lag standby.
Okay.
There is no scenario where you should see three fans running.
Now,
You should always have a standby fan just in case one of them fails.
if you ever needed it, the logic's in place to run all three at the same time. If we use the same logic for lead lag as we use for lead lag standby, we just flip a bit inside the program to say keep only ever run two. So, you want to talk a little bit about the staging?
Yeah. So this is kind of all of these tables over here are
Common to a lot of equipment that has multiple stages.
You'll see it when we get to the central plant stuff as well. This is kind of some of the tools that you can use to determine how the system is running. For example, top status. This is just very basic. This just tells you which fans are running, what their order is. So we've got 6A, B, and C, 6A, B, C, and it tells you what order that fan is in the sequence of operation. So right now, 1 is your version. A is 1, 2, or B is 2, C is 3. That's the order in which they'll come on currently. If any of these were to fail, or if you needed to put them out of service, you can clear that failure. It might be a little bit hard to read from here, but it says manual clear failure. When the fan fails, there is latching logic in the program that will keep that fan locked out until you have established that fan is allowed to run again. So
or all the fans,
or all of them fail.
All of them fail, and then it'll release them all and try to start again.
The idea is that, if anything were to go wrong, they want you to get eyes on it before you go and, before it just goes and tries to run it again anyway. On the other side of that, if you wanted to just turn one off, the easiest way to do that, if you want the system to keep running, if you do want to turn one fan off, the easiest way to do that by far is to just turn this and just click maintenance mode here, and I can do it really quick. Accept. You click maintenance mode here, and then you click accept. It'll take that fan out of the sequence and just run whatever else is available to run. That's by far the easiest way to do this. There's other ways to do it that I don't really recommend. I mean, you can turn the drive off. There's nothing wrong with doing that. But the program is going to think that fan has failed, rather than just saying, okay, the program knows that you put it in maintenance mode. It's not even going to try with that fan. It'll continue operating otherwise. If you were to turn the drive off, it absolutely can do that, but it's just going to think that drive has failed.
I just wanted to mention, because we didn't talk about it at the beginning, everything in web control that you're going to use to affect the system is a two-step process. You're going to click here on the screen, go into maintenance, and they're going to ask you to accept. So if you did want to throw something in and see, you remember that it's not actually going to take effect until you accept. So anything else isn't going to change anything fundamental on the system. Like in trends, you can click on a checkbox and it immediately happens. But if it's something that's going to affect the controller, it's going to affect the system, you click it on the screen, it's going to ask you to accept. Always two steps.
This next table here, this kind of determines the staging of each fan. we spent a lot of time tuning this. I don't anticipate you guys will have to mess with the actual staging parameters of the fans unless something's not working correctly. This really kind of just looks at the parameters that have to be in place to bring on another stage, and it also tells you how many stages are currently active. So over here on the left, normally these numbers will be gray. If that stage is active, the number turns white to tell you that it's active. There's some built-in delays to bringing on these different stages. These are these middle two columns here are the parameters that determine the extra stages coming on. So right now, stage 1 should always be on. So the parameter that determines whether that comes on is if fan speed is greater than -1. It's always going to be greater than -1, so it's always on. Stage 2 is the only one we ever expect to come on and off. Stage 3 is your backup. Stage 1 is always on. Stage 2 will come on, and stage 1 is over 95% for a certain amount of time. Right now we have that, I think it's 3 minutes at the moment. It needs to be on for 3 minutes before it'll bring on stage 2. And then this last block here, this determines the sequence of your fan. So while this gives you a lot of information about which fan is doing what, this last block gives you the ability to manually select different sequences. So right now, it's picking A, B, and C as 1, 2, 3. Let's say you wanted A, B, and C to be 2, 1, 3, or 3, 2, 1. You can go in and it'll tell you 1, 2, 3, 3, 1, 2, and 3, 2, 3, 1, and you can just click on, you manually select that sequence, and that will override whatever the automatic sequence is currently. By default, it'll rotate. You can determine how often you want the fans to rotate. If you want it to rotate, which one is the lead every day, you can do that. If you want it to do it weekly, you can do that. If you want it to do weekly on Sundays, so that most people won't be disturbed by the rotation of a fan, if they're working in these labs. All of that is flexible, or like I said, you can manually pick. I absolutely want it to be 1, 2, 3. I don't want it to try to change who's the lead at the moment. I just want this sequence, then you can override it there.
But all this stuff should happen automatically.
Yes.
This is all of this stuff here is just usually like a reaction to some sort of a problem.
Correct. Normally, you should never have to really look at this stuff unless you're doing maintenance or something is happening.
So I'll talk a little bit about just for this graphic, something in general. We try to put these boxes in our graphics for the purposes of logging information. So there's a place here for notation. So if somebody's doing some work on it, and then maybe there's a static pressure sensor that wasn't reading appropriately, I come in and I say, okay, today is the 7/14, so it's 7/2. Now I put that in there, and that persists. I click accept, and that'll persist for as long as it's there. If you want to come back and delete it, you can, but it's just a way that you can do whatever you want. Keep a note right on the screen. Replaced. I replaced the sensor, or sensor not reading as of this date, needs to be replaced, waiting on cars, something like that, right?
All operators that have access to, which by default most operators do have access to see the notes, all operators will be able to see that when they go to the screen.
So maybe now is a good time for us to walk around and take a look at some panels so we get the blood moving again. So I feel like you and I have been talking nonstop.
Yeah, they've released a few. Yeah, within the last couple of years, they've been releasing a lot of new graphics. I mean, their old graphics work well.
They're inside the curve. They're in the curve.
There's just a lot more functionality, and they're a little more higher resolution. I mean, it's tobacco, right? We're not working on the CRT monitors anymore. It's more resolution. These are made for 1080p, 4K monitors.
Well, for these are the bleeds. So these are not a percentage. They're two positions.
The reason why I like to send it over there is to tell you sometimes they get stuck open.
Feedback. So it doesn't have feedback. Generally, no. Like if you buy a two-position actuator,
Right, it's open and closed.
yeah, it's open closed. So there's like these particulars are. Well, no one would know better than